Hello everyone, welcome to this video. In this video, we are going to learn about TransformerTS using OpenMathAI. So, let's get started. What is TransformerTS? Transformer for Time Series is a supervised deep learning algorithm used for time series forecasting. It is especially useful for predicting future values from sequential data, such as energy demand, renewable energy generation, and industrial sensor measurements. Unlike traditional forecasting models that mainly depend on recent observations, TransformerTS uses a self-attention mechanism to learn both short-term and long-term relationships by analyzing all previous observations in the input sequence. This enables a model to identify the most important historical information for making accurate future predictions. During training, the model analyzes a historical time series data, learns the temporal relationships between the input features and the target output, and continuously updates its network parameters to minimize the prediction error. During prediction, the model uses these learned temporal patterns to forecast future values for new time steps without retraining the model. We will use an energy forecasting dataset for the TransformerTS model. This dataset contains 500 sequential data samples. The input features are time step, hour, solar power, MW, and wind power, MW, while the target output is net load, MW. During training, TransformerTS learns how the historical values of solar power, wind power, and previous time steps influence the future net load over time by automatically assigning greater attention to the most relevant past observations. Once the model is trained, OpenMathAI uses these learned temporal relationships to accurately predict future net load values for upcoming time steps without retraining the model. So, let's get started. Open OpenMathAI. In this demonstration, we use energy forecast by using TransformerTS model. Click Create New Project. Enter the project name as TransformerTS. Choose a folder location to save the project, then click Save. To import your dataset, either click Load Example Dataset or browse for Dataset to import your own CSV file. Once the dataset is loaded, verify that it contains all columns before proceeding to model training. Scroll down to view the first 10 rows of sample data. Click Continue to Configuration to proceed. Configure the dataset by specifying the input features and output target. There's also a feature called Ignore, which can be used for columns that should not participate in model training. Select the input and output columns manually or use Smart Suggest for automatic recommendations. There's one more feature, Signal Diagnostics. There's a free columns. First one is column it tell which features on the dataset like inputs and outputs name. Second one is VIF if it tells how much correlation of the features. Third column is status if it's okay, moderate, high, redundant, and constant. Review the selected configuration. Click Proceed to Model Design. Choose a model from the available machine learning models. OpenMathAI recommends suitable models and features based on the dataset. For this demonstration, select the TransformerTS model. View the model overview, pros, cons, and real-world applications. Click Proceed to Training. You will see the selected model. Click Train Models. Review the training configuration, test data split, which determines a percentage of data reserved for testing and validation. Review the model parameters and pre-processing settings. And also the another feature is added that is trained from scratch or continue from use model. If you train this model before you use that option, modify the configuration if required. Click Start Training to begin the training process. After training is complete, review the following performance metrics. R-squared measures how well the model explains a variation in the output data. Range 0 to 1. MSE, mean squared error, measures the average squared difference between actual and predicted values. RMSE, root mean squared error, the square root of MSE. RMSE is expressed in the same units as the output variable, making it easier to interpret. Engine time, the time required for the generated model engine to execute and produce predictions. Lower engine time indicates faster model execution, which is important for embedded systems and real-time applications. Fit quality, an overall assessment of how well the model fits the dataset. It is generally derived from tricks such as R-squared, RMSE, and residual errors. Model accuracy is commonly estimated using the R-squared value. Example, R-squared equals 0.95 accuracy, almost equal to 95%. Click Fit to Window. You will see 3 types. Fit to Window, comfortable, compact. Then the Clear History. If you click that, it will clear the history before its trained model. Another is Deselect and select all trained model for export. Click View Curves. You will see the diagram of R-squared residuals and residuals diagram. Click Math and Code Preview to view the mathematical model generated by OpenMathAI. Open the Math view to visualize a complete TransformerTS architecture. Maximize the window and scroll down to see the complete model. The preview displays a TransformerTS architecture, mathematical equations, generated source code, and a detailed explanation of the forecasting process. The visualization shows how the model receives the input features. The input data is organized into windows, encoded, and processed by the transformer encoder to learn temporal pattern from the historical sequence. The encoded representation is then passed to the prediction layer to estimate the future net load MW. During training, the model learns the temporal relationships between the historical input features and the target output. Return to the result page and click Deploy Status. Click Export Model. Choose the required export format: ANSI, FMU 2.0, FMU 3.0, Verilog RTL, VHDL RTL, Python Bundle, ONNX Hub. You can choose any of these formats and export. You can also download the free trial versions of OpenMathAI and Twin Simulate. Thank you. Stay tuned for more OpenMathAI demonstration.